This edition of Improve Your World with SUNY ESF is ESF in Space.
Honestly, the most enjoying experience is probably being able to go to space. I mean, essentially, we don't go personally, but we bought a balloon and we were physically able to see what's in space.
Our calculations show that it probably reached 110 or 115,000 feet. 15 students are taking the class, 12 of them are juniors, 3 of them are seniors.
Yeah, every little kid has a dream, you know, like they see the stars and they're, you know, so much curiosity at that young age. They want to know what's up there. We were physically able to do it on a very low budget. Instead of buying like a space shuttle, you know, we bought a helium balloon and we got up there.
So we're trying to see how can we improve the technology to get up there in the cheapest and safest fashion, while at the same time we are teaching our young engineers how to design, execute, build and potentially test different engineering principles. Because to get up there you need to have expertise that involve chemistry, physics, even statics and mechanics. And at the same time it's a combination between the knowledge that you have but also the innovative factor that it's necessary once you get out there in the market environment.
In the early part, yeah, there was a lot of procrastination, you know, because we were kind of unsure how serious the project was, what everyone's duty was. But once we kind of had to get to some deadlines, things kind of picked up. People took roles, and it just naturally fell into place. You know, Yorgos was a good mentor, so was Chris Summerlot. They kind of pushed us, edged us, and once we got the ball rolling, it wasn't stopping. Honestly, this whole project is like a real engineering kind of practice. You know, you work with people, you might not be familiar with them. You work with professors, you know, you got your trained engineers, and you have people that are still learning. You know, it's all a learning process.
Don't forget to do that.
Okay, and if you want to put a little bit of tape just to hold it, that should be good.
We've already used so much duct tape.
The fundamental thing when working as an engineer is group work. So if you learn how to work with other people and learn how to do independent study.
Can you hold beforehand? Yeah. Because when I left the house,
The second time I got it.
That's moving back. That's moving back.
After a successful liftoff from the ESF quad, we get the view from inside the payload. See the students lying on the quad, spelling out ESF. You're looking at Oneida, Onondaga, and the Finger Lakes from around 110,000 feet above the Earth. Let's go back a few weeks to see how the team put all the pieces together.
We've been gathering several Sundays here on campus in our own little room there doing the development and testing of the equipment, and it's difficult to predict how it's going to behave at minus 40 degrees and 100,000 feet above the ground.
So this is a Kodak 360. It's a camera. It can essentially take a picture of anything in front of it. So we use it on the payload, and we can get not only anything that's happening on the ground, but also the balloon at the same time. So we can get a huge kind of field of view in our images.
This cone shell protects the payload, the camera, and other instruments.
So this has a GPS chip inside here, and this will transmit these data packets across this thing called the iGate, which is like a Wi-Fi network that the APRS uses to transmit radio signals with data packets, and then we can track that online through the Wi-Fi.
It's going to move quite a bit, I think. Well,
It's kind of heartbreaking into the semester because we started committing our Sundays. Every Sunday, you know, we all came in and we worked, and it was probably like a 6-hour day, you know, on a Sunday, and we'd start early. So like, there was this sense in the class where I was just like, we're committing a lot of our free time to this. And then we did the last launch, and there was all this attention, and it was a big excitement. And then, you know, it just kind of, we lost it. We did the launch on the last day of classes, and then we just never found any of the stuff again. So it was like, it was just a heartbreaking thing, you know. It was like, what did we actually put our time into? And then, you know, like a couple of us actually went down to that area and looked for it on our own time. But it was just, you know, trying to find a needle in a haystack. Couldn't find it.
it was on a side of the mountain that would not be able to communicate directly to a receiver.
Yeah, and then Yorgos, you know, actually gets a call when he finds it a month after.
Someone called our undergraduate admissions office, and they told us that they actually found the balloon. So I got that person's contact information. I called him right away. I asked for a specific description just to make sure it was the right one, and he gave me all the information we were looking for. We got really excited and then decided that this was the one. So got the address and ran down there to pick it up. In terms of landing and the overall the payload design, we're happy with what we got. It was intact. It was almost in the same condition as we let it go. So it was like seeing an old friend come back. And it's also a learning experience in terms of how to integrate all the components and the programming aspect of that. So we certainly have some ideas on changes we will be doing next time.
It was a ton of fun, you know. It's just from the basic level of, you know, you literally hold something on the ground and then you let it go and it goes 110,000 feet and you can record it and get images from that. That's just cool because, you know, we're all into science.
That's it for this edition of Improve Your World with SUNY ESF. We hope to see you again next time.